Hello, let us see few topics in superconductivity. So what is meant by superconductivity? Certain materials, when you put them in very low temperatures, very near to absolute temperature, that is 0 Kelvin or minus 273 degrees Celsius, this material shows zero electric resistance. So zero electric resistance means there is no opposition for flow of electrons. So the current conductivity is very high, resistivity is very minimum or like zero. So if you take a graph and put temperature Kelvin versus resistivity, in normal materials what happens is this resistivity goes on decreases. So then it remains something at 0 Kelvin. At 0 also you have some resistivity. But if you take a superconductor, so this superconductor, what happens is at some transition temperature Tc or critical temperature, so what happens is the resistivity becomes zero. So this is called superconductor. So this is normal materials. So normal, and this is called superconductor. So it conducts very fast. So that's why the name superconductor. And also it shows another property that is called Meissner effect. So what is Meissner effect is, so if you apply external magnetic field for these materials when it is at 0 Kelvin or very low temperature, what happens is this material repels the external magnetic field. Suppose initially you have a magnetic field applied and the magnetic lines of forces go through this. So the magnetic lines of force passes through the material. But if you bring this to 0 Kelvin, what happens is this magnetic lines of force will be repelled by this material. It will not enter inside the material. So this B, magnetic field induction, will become 0. So this effect is called Meissner effect. So there are a lot of applications for superconductivity, magnetic elevation trains, and also in quantum computers now we are using this superconducting ions. So lot of applications are there for superconductors. Um, I will be explaining little bit about the very important topic. Um, Before going to that, let us see what are the types of superconductors. There are two types, type 1 superconductors and type 2 superconductors. So if you take type 1, what happens in type 1 superconductor is, if you check the magnetization of this at up to certain critical magnetic field, so the magnetization increases and then suddenly drops. So this is called type 1 superconductor. So here it shows diamagnetism. When it is superconductor, it shows diamagnetism. Then magnetization increases and suddenly it drops. This is type 1 superconductor. In type 2 superconductors, we have this magnetization increasing with external magnetic field up to certain point, and then it doesn't drop suddenly. It goes very, it doesn't drop abruptly, so it goes gradually decreases. So this point is critical field 1 and this point is critical field 2. So this is called mixed state, where both you have normal state and above that it is called normal state. So you have mixed state, vertex state, we can say. Type 1 superconductors are called as soft superconductors, and type 2 superconductors are called as hard superconductors. So there are a few materials which shows type 1. Only thing is the critical magnetic field is very low in this case, whereas the critical magnetic field is very high in the case of type 2. So this superconductor is explained by BCS theory. So BCS means then three scientist names, first letters of three scientist name. What BCS theory explained about the zero electric resistance and Meissner effect is, they told that these electrons which is moving in the superconductors are moving in the form of pairs um, under the influence of ions in the material. So if you take a material and you have free electrons and the ions, so this electrons are moving in the form of pairs, and these pairs are called as Cooper pairs. One of the scientists' name is Cooper, so they named after him Cooper pairs. So what happens is these electrons, according to quantum theory, they move in the form of waves. So these waves will be moving under the influence of positive and negative, because they are electrons, so the negative they attract, and then when they come the ions will attract the electrons. Then when they come near, again these electrons will have Coulomb force, they repel. Again they attract, repel, attract, repel. They move in the form of pairs. So based on this, they were able to explain the zero electric resistance and Meissner effect. Finally, let us discuss Josephson junction. What is Josephson effect? So what Josephson has observed is, you take a superconductor and another superconductor, insert a insulating material, a thin insulating material between two superconductors. Thin means in the level of 1 to 10 angstroms. So if you keep those, suppose if it is copper, you can take cobalt oxide or something, then copper. So what he observed is, the electron pairs, Cooper pairs, will penetrate through the barrier and comes to the other side. So, and he observed there is current due to this, that is called super current. So what is super current? If you see, now there are two types of Josephson effects. So one is DC Josephson effect. Another one is AC Josephson effect. What is DC Josephson effect? Now the electrons which is moving in this superconductors, now if you don't apply any external voltage, we are not applied any external voltage, but still this Cooper pairs crosses this barrier and it produces some current. That current is called super current. So the value of super current Is is equal to Ic sin phi naught. So this phi naught is the phase difference between these two waves of Cooper pairs. So when entered and then when it comes the other side, it will have some phase difference. So the phase difference without applying voltage, it produces some phase difference and it gives some current, that is called super current. So this type of effect is called as DC Josephson effect. In AC Josephson effect, the same thing is happening, but what is happening is we are applying some voltage. When you apply some voltage, the current that comes will have additional phase change. So the current in the AC Josephson is I is equal to IC sine phi naught plus delta phi. So this delta phi is additional phase change that comes due to the applied. So here no applied voltage. Here we are applying voltage, and here the current that comes is a DC current. That's why it is called DC Josephson. And here the current which comes out is a AC current, alternative current. So that's why AC Josephson effect. And this delta phi is given as 2 pi t 2 eV by h. So where this 2 eV is the energy difference between two Cooper pair electrons that is coming out of the junction. So that is the energy difference between two electron that is coming out through junction. So it has 2 eV. So you can substitute this delta phi here and find out the net current that is coming in the AC Josephson effect. And if you see the frequency in this AC Josephson effect is 2 eV by h. Whenever a microwave pulse or electromagnetic pulse which has this much energy is sent through this superconductor, they get observed or emitted. So this is useful in quantum computers, where we define the qubits with this superconducting ions or the current. So the current is varied by applying microwave pulse. So by certain pulse the current is fixed. By changing the microwave pulse the current is changed. So this change is represented as different qubits in quantum computers. So this is all I want to explain to you about the superconductivity. Hope you have understood these topics and it will be helpful for your preparation. Thank you.